Hi guys, and welcome to my lab 4 video on rope physics. In this lab we will be analyzing the motion of an object hanging on a spring and moving in two directions. The objectives of this lab are to analyze the two-directional motion of spring mass system using tracker, and to create a computational model using VPython, and finally to compare the model with the observations. The fundamental physics concepts involved are Newton's second law and the energy principle. Now let's look at the analyzed video. You can see that the software creates a graph of the observational position versus time. And here we can see the observational data the software provides us with. Using this data, we can acquire the required system properties for modeling this experiment. Here you can see that I have set the appropriate system properties: the ball's mass, its initial position, its velocity, an appropriate delta t, the constants, and inside the loop you have seen that I have set the appropriate value for the different forces, and F net is equal to the sum of the gravitational force and the spring force. Here you can see Newton's second law, and using that I have updated the position. Let's run this and see what happens. You can see that it works quite okay. Now, they had also asked us to compare the observational motion with the model motion. Now let's do just that by running this. Here you can see that the two curves align with a bit of difference. The difference is mainly due to ignoring drag force. There may also be other forces acting on the system, but which we are neglecting. Now let's move on. They have also asked us to differentiate between the time period acquired from the X position and the time period acquired from the Y position. Using the X position, we get that 4t equals 6.458 second, and so t equals 1.615 second. And if we are using the Y position, we get that 4t is equal to 6.078 seconds, and therefore t equals 1.519 seconds. That's all. Thank you for watching my lab video, and see you next time.